Hi, this is Professor Stugard, and in this video we're going to be investigating limits with technology. So our only really goal for this video is just to use technology to investigate limits, and specifically we're going to be looking at how to use our TI-83 or 84 to do so. So first, let's say we're given this function f of x equals sine of x over x. And I want to evaluate what is f of 0. So meaning I plug in zeros everywhere that the x's are. So I get sine of 0 over 0, and sine of 0 is obviously 0. So we get 0 over 0, and we cannot divide by 0, which means that this is undefined. Now, as we've kind of already talked about, this isn't good enough anymore. We need to dig a little bit deeper. Just because something's undefined doesn't mean that's the end of the problem. We need to figure out, well, sure, this is undefined, but should something else maybe have happened? So what we're going to do is take a look at the values when x is very, very close to 0. So what this means, the limit as x approaches 0 now of sine of x over x. And remember, when we do this, we have to look at values that are both greater than and less than 0, meaning we have to look at both the right-hand and the left-hand side of our limits. And the way I'm going to do this now is by kind of organizing everything in a table. So we can see that this first column, we have x approaching from the left, or values that are smaller than 0. And in this column over here, we have values approaching from the right, or values that are bigger than 0. And we can kind of see that the way I have organized my table here, that the values are getting closer and closer to 0 as I move down this table. All right, so let us take a look at how we can evaluate this on our TI-83. So here I have a TI-83. Again, yours might look slightly different, but this is, this is a TI-83 Plus. Now the first thing we want to do is actually put our function into this calculator, and so we're going to do that up here in the y equals. But before we even do that, we need to make sure that our calculator is set up correctly. So we're going to go to mode, and if I look at mode, I need to make sure of a few things. First of all, we need to make sure we are in radians. Everything that we do in calculus has to be in terms of radians for our trig functions. And then down here, I also need to make sure that I'm in my typical functions, FUNC. We also have PAR for parametric and POL for polar, and again, those are things that we might investigate a little bit later. Once I make sure those are there, I go to my y equals. Now, if we have some functions stored in there already, let's make sure that we clear those out so that we can enter our function. So again, our function here is sine of x, so I hit my sine button. This button up here is my variable button, and so the first one is x, and so that'll automatically give me x. If I'm in functions, t for parametric and, well, theta for polar. So sine of x, and then I need to make sure I close that parentheses because, again, I'm evaluating sine of x, and then I am dividing by x. So I'll press enter, and good, I have that stored in my calculator. Now I want to fill in my table. So the best thing we can do is actually, we have, again, the options for going to our table here, but first, let's make sure our table is set up correctly. Just like when we graph, we want to set up our window, our viewing window. We want to make sure our table is set up for our purposes as well. So, because it's in yellow or that different color, I need to hit that second button. Then I can hit this and I get to my table setup, right? So table setup, table start, the delta table, which again tells me how my variables would be changing. But I'm actually not worried about that because I want to go down to where my independent variable is. So my independent variable being x, and instead of it autofilling my table, I want it to ask me exactly what value I should be plugging in for x. So I'm going to set that to ask. Now I want my table. Again, the table is in that other color, so I have to hit second, and then the graph button, which brings me to my table. And I can see the x and the y. And so I can start filling in the values from my table. So that left-hand column, the first one was -1, so I can type in -1, and boom, if I plug in -1 into my function, this is the decimal value that pops out. And so I'll write that down in my table, then -0.1. That was my next one. Press enter, and I get 0.99833. My next value is -0.01. I press enter, 0.9998, and then my last one, negative 0.001. And I press enter, and I told you that that's 1. So I get the exact value 1. Now, is that really what it is? Well, not quite. Okay, we can use these arrow buttons to navigate, and if I navigate over and up to that 1, we can see that the calculator is actually rounding. The true value is 0.9999998. And so what the calculator is doing, there's not enough space to write that, so the calculator is rounding to fill in the spaces as 1. All right, so now I can go back over, and I want to do the other column in my table. So that started with positive 1, and so positive 1 is 0.84147, and then positive 0.1, enter, 0.99833, then 0.01, enter, 0.9998. Oh, I'm getting the same things. This must be one of those symmetric functions. That's the same about my y-axis. 0.001, enter. Again, it's displaying 1, but really it's the 0.99999. Oh, wait, did I? And so I have all my values. Again, hopefully I wrote those down. Notice that, again, because it asked for them, I can ask for whatever values in my table, but I can only really display what's going to be, is going to fit on this screen. So let's take a look at that table now with everything all together. So I've recorded all these in my table. If you notice, down towards the bottom, I have said that it is approximately 1, since again we did some rounding there. And now the idea is, well, now that I look at this table, do I see any patterns in my data? Do I see something that my f of x function is approaching or getting closer to as my values for x get closer to that 0? And so I'm looking at those f of x tables. I'm looking as I get closer to 0, is there a pattern to those values? And, well, yeah, it looks like they're getting really, really, really close to 1. In fact, again, that last value is practically 1. And so it appears that the limit is approaching 1. And so from our table of values, our best guess is that the limit as x approaches 0 of sine of x over x is going to be equal to 1. Now, that's our best guess. That is not a proof. We don't know that for sure, although we'll probably show this is true maybe in just a little bit. But for now, that's just our best guess. We don't know that for sure because we didn't use algebra. We just use a table of values. And again, sometimes that's all we can do is our best guess. We should also take a look at the graph too. That's always a good place to work as well. So let's take a look at the graph on our TI-83. So with our TI-83 now, what I want to do is to set up my window. So we should set up our window first. Again, I gave you the parameters there. We're going from -6 to +6 for my x min and x max. So again, that's my horizontal. We can keep the x scaled as 1. Again, that's just where the tick marks are going to be on the axis, and in this case, 1 makes sense. And y min, -2, y max, +2. Again, we can keep the y scale the same. And again, we could play around with this, and again, you might not know the exact window, and again, it's good that you can kind of play around and look at this. And so I have my window set, and now I can hit graph, and if I hit graph, I take a look at this function. And yeah, I do have that symmetric about my y-axis like I had expected. And since all my tick marks are on the integer values, when x is 0, again my axis, it definitely looks like it is approaching 1 from both sides there. Now, if I want, I can always actually zoom in, so I can actually do the zoom in, and then from there, I can use the arrow keys to navigate. I want to zoom in right around that x equals 0, press enter. And it's going to show me, yeah, sure enough, it does look like it is approaching 0. Just remember that with the technology is, picking values to plug in, just like we did with the table and then plotting those values. You are not going to see the holes or the gaps when we use technology. So we know that it is undefined here at 0, but no matter what technology we use, it's probably not going to show that to us. But again, now we have a little bit more confirmation that yes, this limit probably is equal to 1 as x approaches 0. So, like I said, with some confidence, all right, I'm fairly confident that that limit as x approaches 0 is equal to 1. Okay, so on your own, I want you to try to do the same thing with this new function, sine of pi divided by x. Now again, we can try to evaluate this function at 0. So in this case, my function is g, so I'm evaluating g of 0. And so if I plug that in, pi divided by 0, well, if I try to do that first part, what is pi divided by 0? Well, that's undefined. And so anytime I am dividing by 0, even in something like this, it is a composite function, right? We have a function inside of a function. We have that pi divided by x inside of my sine function. As soon as I get divided by 0 anywhere, this has got to be undefined. So let's do the same thing. I want to investigate what happens when x gets close to 0. So the limit as x approaches 0 of sine of pi over x is equal to what? So that means, again, same thing. We got to look at values that are both greater than and less than 0 so that we come in from both sides, the left-hand side and the right-hand side. And so what I want you guys to do is fill in this table. So pause the video right now, go back into your calculators, plug this in, and figure out what values go in this table. I'll wait. Waiting. Hopefully, did everyone do that? Is your table filled in? I hope so. So I got zeros for everything. So is there a pattern to the zeros? Clearly 0 is the answer. It clearly seems like everything is trending towards 0. It appears this limit is approaching 0. So, okay, can I be sure of that? Well, wait a second. Let me just double check the graph. So I opened up my TI-83 again. Now I'm going to type in my y equals sine of pi divided by x. My window, I had zoomed in, so it's a little off. So let's go back to our -6, 6, -2, 2 for my x min, x max, and y min, y max. Let's graph this. Let's see. Sure, coming in. Looks like it's... Whoa. What did it do there? It kind of looks like it might be 0. I don't know. Kind of hard to see. So again, let's zoom in. So we zoom in around 0, 0. Let's see. Oh. Okay. Well, again, some up and downs. That looks a little weird. Let's zoom in even a little bit closer. What is going on here? Well, it is bouncing back and forth like a crazy thing. So is it actually approaching that value? Well, in this case, no, it's still bouncing back and forth. It's not actually approaching one value. This function's kind of going crazy. It keeps going back and forth and back and forth, and no matter how close I zoom in, it's just bouncing back and forth and back and forth. And one of the problems is, again, this technology, with any technology, it's just picking random points, plugging it in, and then connecting the dots. And yeah, there's definitely something weird going on. So does this function actually exist at x equals 0? Well, we know it doesn't exist. Does the limit exist? No, I don't think this limit exists at all. So, can I be sure my limit's using just tables or graphs? No. Technology always lies to us. We need to figure out better methods of investigating these things. Computers are incredibly useful. These tools and these machines that can do calculations for us are incredibly useful. They have a very important role in all of the mathematics that we're going to do. But we still need that human element to try to figure out what is going on. All right, so this pretty much wraps up our quick video on how to use our TI-83 or 84 so that we can evaluate functions really easily. Again, remember this trick for later on. If we need to evaluate any function easily for multiple values, we can plug it in and use those tables, right? Where we can actually set our independent variable. All right, so that wraps it up for this one. And as you guys are exploring calculus, make sure that you take care of yourselves.